Find functions f of x and g of x such that limit x approaches 0 for f of x plus g of x exists, but limit of function f of x when x approaches 0 and limit of g of x when x approaches 0 do not exist. So that is the kind of question now we have. Now how is it possible? Is it possible or not? Okay, a function, think about a function whose limit does not exist as 0. So first part is very easy. So we can have a function like 1 over x, right? So we have a function here which is like 1 over x, right? And we know 1 over x is kind of like this, and we say f of x equals to 1 over x, right? Now its limit does not exist as 0 because when you approach from the right side you're approaching positive infinity, and from the left side you're approaching negative infinity. So we got this function, right? Its limit does not exist. And what should be added to this function so that, that is whose limit is not here but the limit of both could exist. So this is a very tricky problem, and the solution, if you know, is very easy, otherwise very difficult. So what I say is, so let us say this is this, but how about thinking of g of x as minus of 1 over x? So that means I will have a function like this, right? Minus of f of x, right? Now, algebraically, what will happen is that if I have combination of this, so if I have a function, so let's consider now a limit of function x approaches 0 for f of x plus g of x, right? So f of x plus g of x. So what do I get if I am choosing this as my function, right? So I have limit x approaches 0, f of x is 1 over x, right? Plus g of x is minus 1 over x. Now if I do that, then clearly I have limit of function when x approaches 0, and here this minus this is actually 0, which will give me 0, right? So in a way I do get a limit of the combination of these two functions as 0, whereas the limit of individual functions does not exist as x approaches 0. Mind it, remember, we are not going to the point 0, okay? We are approaching 0, we are not at 0, right? So even for the combination, we say that x is not equal to 0, okay? That's very clear. We are not going to 0, right? At 0, both don't exist, but limit means going close, and very close to 0, okay? Not at 0. So there is a discontinuity at 0, which you should appreciate, okay? I hope you appreciate this, and this kind of question normally does come in communication, okay? Thank you.